The circle C has the equation x squared plus y squared minus 2x plus 14y equals 0. I need to find the coordinates of the centre of the circle and the exact value of the radius. So I'm first going to group up my x terms together. That's the x squared minus the 2x. Then I'm going to group up the y terms together. So that's the y squared plus 14y. And I'm doing that because now I can complete the square on the x parts and the y parts separately. So completing the square on the x parts, I'll get x minus 1 all squared minus 1 squared. Now the y part, I'll get y plus 7 all squared minus 7 squared. I'm now going to take the minus 1 and the minus 49 to the right-hand side. So the minus 1 and the minus 49 will turn into a plus 50 on the right-hand side. So this minus 1 is telling me that the x coordinate of the centre of my circle is plus 1. And this is telling me that the y coordinate of the centre of the circle is minus 7. So that's my answer to part A. That's the coordinate of the centre of the circle. The 50 over here, that's my r squared. The radius squared is equal to 50. So the radius would be the square root of 50, which is the same thing as 5 root 2. And so that's my answer to part B. Part C. The y coordinates of the point where the circle crosses the y-axis. So I know it crosses the y-axis when x equals 0. So I could either make x 0 here, or I could just take that original equation and make x 0 in that. I'm going to do that. I think that's easier, because that will mean I don't need to expand these brackets. So I am going to substitute 0 here instead of the x, and here instead of the x. So that's going to leave me with a nice simple equation, y squared plus 14y equals 0. Factorise the y. And so I can say that either y is 0 or y is minus 14. These are the two y coordinates where the circle crosses the the y-axis. Finally, part D. Find an equation of the tangent to the curve at the point 2, 0, giving my answer in the form ax plus by plus c equals 0. So I know that the tangent is going to be perpendicular to the radius. So if I work out what the gradient of the radius is at this point, I can then do the negative reciprocal of that to get the gradient of the line that's perpendicular to the radius. Therefore, that will be the same as the gradient of the tangent. So if the centre of the circle is 1 minus 7, the gradient of the line between 1 minus 7 and 2, 0. Let's do that. So the change in the the change in the y coordinates is going to be 0. Take away negative 7. The change in the x coordinates is 2 minus 1. So the gradient of the radius is 7. That means that the gradient of the tangent will be minus 1 over 7. I can now do y equals mx plus c. Using the coordinates 2, 0, because I want the tangent that's going through that point. So if I substitute that in now, so 0 equals minus 1/7 times 2 plus c. I find that c has to be 2/7. Therefore, my tangent would be y equals minus 1/7 x plus 2/7. And now just to rearrange it in the correct form. So times 3 by 7. And then move everything over to the left-hand side. So I'll get x plus 7y minus 2 equals 0. And there we go.